So when it comes to solving a system like this is again a system because we have two variables. However, this is a quadratic system in terms of x. Okay, so we're going to end up with two quadratic functions. So one of the quadratic functions, okay, maybe I'll do different colors here. So this quadratic function, okay, it's going to be a quadratic function kind of looking like that. Okay, and then we have another quadratic function here. And when we graph this again on decimals, it's going to be kind of a narrower quadratic function, and it's going to look like that. Okay, and it's a little bit hard to tell, so we have to zoom in a little bit, but it appears that our solution is here. Okay, when it looks like the solution is at x equals 1, y equals 2. So if I plug in 1, 2. Okay, so it looks like, it looks like x equals 2, y equals 1. Okay, so our solution is at 2 and 1. So just double checking that. 2 squared, 10, y equals 1. 2 squared times 2 is going to be 8 minus, it's going to be 2 squared, 8 minus 2 minus 5, it's going to be at 1. So our intersection looks like this. Now, our solution for this then is x equals 2, y equals 1. Now, we should mention a few things about this because this is a quadratic. Now, it's really, really hard to tell visually that there's only one solution because that's a tangent. Okay? So we have to kind of think of what types of solutions should we be looking for when we have different combinations of systems. So the type of systems that we're going to look at and we're going to encounter in this unit are linear, okay, a linear quadratic, and a quadratic. And so we know that in a linear system, we have two straight lines. We have one line and another line, and we're just going to get one solution of x and y. So when we look at a linear quadratic situation, we have to consider how many solutions are possible. Okay, so when we look at a linear quadratic solution, we can have two solutions. Okay, so a two solution situation would be when we have a quadratic and we have a linear function and it intersects at 2 points. Okay, now we could think, okay, well, what about three solutions? Well, that's not possible because if we actually think of a quadratic, the highest degree is 2, so really the most solutions we should end up with is 2. Okay, so this is two solutions. Now, is it possible to have one solution? Well, we can draw a few different cases. Okay? A one solution case is when we have our quadratic, so I can draw it upside down in this case, and we have a linear system, and it just touches. Okay? So it just touches there, and that is a one solution situation. Okay, so it is possible that a linear quadratic system can generate one solution. And what about zero solutions? Well, a linear quadratic very easily can have zero solutions because when we have a quadratic and we have a straight line, well, it is possible that this line does not cross the quadratic function. So we do have a situation where we have zero solutions. Okay, so these are the three cases for a linear quadratic. What about a quadratic? Well, quadratic case, well, since it's quadratic, we really should think, okay, well, our highest degree is 2, so really we probably can't have more than two solutions. So if we think of it, can we have three solutions? Well, we really can't draw a case with three solutions. However, I can draw a case where I have a quadratic and a quadratic that intersect 2 times. Okay, so this is a two-solution situation where I have one solution here and one solution here. So that is an example of two solutions. Okay, we do have other situations where you have two solutions, and we can actually have two solutions with the parabolas opening the same way. So I can have a thin parabola with a wide parabola, and I can end up with two solutions that way. So there's our two. We have possibly two solutions, and we can draw a case for that. So what about one solution? Can we draw a quadratic case with one solution? Well, one way we can do this is we have seen it where we have a parabola and a different shaped parabola, and it just is tangent in one spot. Okay, so that is the case that we just saw. So there's a situation where we can have one solution. We could also have a one solution situation where the vertices match. Okay, so I can have a one solution situation where I've got the vertex just touches, like that. Or I could have the same vertices touch facing the same direction, one narrow and one wide, where the vertices just touch. Okay, so there are more than one cases when we have, or one example when we have one solution. Okay, but we can have one solution, so one solution is algebraically possible. And then we have the zero solution case. Okay, it is possible to have zero solutions. Okay, a zero solution case would be, we have a parabola that's shaped like this, and another parabola that's going in the opposite direction. That would be a zero solution. Okay. We could also have parabolas nested in each other. Okay, a parabola like this and a parabola like this. Okay, and this is either the same shape or narrower, and that would be a zero solution case as well. Okay, so we could have them facing the same direction, but yet also, as if one is nested inside the other, okay, there we can have a zero solution case for that.